Alrighty, welcome to Nick Snacks. Today's snack is yet again the DNVT. I hope you're all ready because we're going to be on this for some time. But we've released some updates to the firmware on the DNVT, and as of yesterday, actually, I've been shipping these out to the first initial orders. So we're just going to cover what we got going on here. For those of you who checked out our last video, we have a kind of a decent description of what the basic functionality is, but we're going to cover some of the newer stuff that we've worked on. So just to recap, this is the current version of the switch. We have ditched the LED version, and these are all going to be display-based. These are the Chinese I2C units. It's sort of, Chinese cell phone type things. Pretty fun little devices. But basically what these are here is just fully self-contained switches that will interface with these DNVTs, provide them power. So they take USB-C, and they can either be from a computer or a power supply. And as well, they also take a high voltage DC, which is usually 48 volts, up to 56 volts on the backside, which gives the power to these. And they can run over quite long distances. We did the math, something like 4 kilometers that you can actually extend 2 twisted pairs out to these types of phones before you get enough attenuation that they won't receive properly. So these are obviously DNVTs. These are the TA-1042s. These are obviously our favorite models. They have kind of a really cool design and a good industrial type UX. And they also support the local battery mode and the common battery mode. But in each mode, they support 16 and 32 kilohertz. With local battery mode, you can set these both to 32 and send them point to point, and they'll ring and sort of interact that way. But when you're ready to connect these to the switches, they're going to have to be set to common battery mode. If you buy one of these other type devices, this is the TA-1035. These have several differences. Number one, they're a little clunkier. They got this kind of metal bracket in the top to seat the phone in. I wouldn't recommend these, honestly. If you can find the TA-1042s, they're better. But these have some subtle differences. The TA-1035 is going to support only 16 kilohertz, although, at least in the ones we've tried, that's the deal. And the TA-954, instead of a data port, it has a selector switch to select from 16 or 32 kilohertz, but they're not going to support the local battery mode, so it's only useful with the switch. So again, make sure before you connect these are going to be set to 32 kilohertz CB. If you end up with a 16 kilohertz only phone, you're going to have to switch every phone on the switch to 16 kilohertz. And it hasn't been implemented yet, but there's going to be a dip switch setting in here to toggle the 16 kilohertz mode. There are mixed compatibility 1632 modes available in the switch, but we haven't implemented them yet, so all 16 or all 32 basically, and we recommend you get a 32 capable phone. So when you plug these into the switch, and if your computer is off or not running the new USB program, this is going to display inactive. And what that means is that this switch is currently in what we're calling line simulator mode. It's basically a demo program that enables you to test out switching up to 4 phones. And I mean, it's quite useful for switching up to 4 phones, but obviously not beyond that, because this interface is going to only have 4 lines total. So what you can do in this mode is, plug up to 4 phones. And one of the new changes is line supervision on these lines. So at some sort of interval, it's going to actually ping out on the line and determine if it can actually talk to the phone. And that's one of the cool things about digital phones, is they'll actually reply when activated. So we can discern whether a line is idle or it is actually unconnected. Just a note on the line supervision feature. This is programmed to query the phone when you first apply power and then every 10 minutes thereafter. And in addition, obviously, if you try to ring the phone, it's going to query that as well. So one of the notes is that when the query actually happens, this is momentarily going to flicker, and you're going to hear a click out of the handset as the phone actually activates when it sends the Q command down the line. So that can be a little bit annoying. So we do have the option with a dip switch to disable that, check the manual, but if you flip that on, it is only going to check for inactivity when the phone is actually rung. So in order to use this, all you have to do is basically connect your phones up, just double check that they're getting connectivity with that line, and then as soon as you pick this up, it's going to go into a dial mode, and that's going to produce a synthetic, it's a non-NANPA dial tone that you can hear there, and that we use that because it actually, number one, it was easier to implement when I was just mashing bits into a single packet to get it to work, but it's also going to indicate to you that this is in a line simulator mode and not in a switch mode through a computer or in any other, console redirection or stuff like that. And then when we provided a normal dial tone from the computer, that's going to indicate that it's not. So it's useful feedback. What we've done is simplified the dial plan a little bit, so every single extension here is going to be one digit for the number of phone. It's equivalent to that there. So you see we've picked up extension 4, and that indicates dial. Extension 3 is idle, so if we go ahead and press that button, that's going to ring. You can pick this up and it'll complete the call. When you're in that mode, you're going to go ahead and see traffic on both. And as soon as you hang up extension 3, that's going to go back to idle, and this is going to return to the dial state, so you can make another call to a different extension, or you can just hang it up like that. In addition, of course, my favorite mode, if you press the R key, I apologize. I had to do it, guys. I had to do it. So in the back here, this is the RJ45 model, and that has 2 RJ45 ports. The pinout is articulated in a rather detailed fashion, so it'll give you the exact color pairs, the phone it's going to, and which color on the phone it should be attached to. Obviously, these are the positive, these are the negative, and each of the 2 positives need to be connected to get the data going in each direction. And then there's 4 lines here, but obviously only 2 RJ45 ports. So for some fun stuff, we implemented, or Rob actually designed these RJ45 adapter boards, and these just kind of plug right into the top of the phone. And because 2 phone lines are coming over this, which is connected directly to the switch over there, we have one to the switch and then one daisy chain capable port. So this is the second phone that goes over to the other port and connects right into the switch port there. So that enables you to run a single Cat5 cable with 8 wires, 4 pairs, and drive 2 phones. And you can connect one or connect a second one off of daisy chain if you need 2 lines in one place. At some point in time, we may offer a splitter. Just be aware that these the pinout is not precisely aligned with the 10100 Ethernet standard, so a standard kind of splitter type device won't work. But the entire pinout is going to be written on the back there for those. You can just chop off a cable and just clamp them down. These work great for that. The other option we have is obviously old school, and we talked about this, but this is the terminal block version, and this is a little bit more expensive because these terminal block connectors are a bit pricier than the RJ45s. But that's going to enable you to insert a bare wire in there. You press down on that little button there with a screwdriver and just insert your stripped, cable you stole out of your your old Ethernet cable, and then that's going to interface with the phone just by plugging it in there. Just ignore the data cable. That's future work. So again, same screen, same behavior, and in this case we only have one line connected on this phone, obviously, and so it's going to show idle. And then this phone is obviously not going to be super useful. But in the line simulator mode, I did actually burn in 2 different tones. So if in this case we have lines 3 and 4 active, if we dial a line that's inactive, you're going to get a busy signal, which is just a repeated tone. This is the connection fail state, as you can see there. And then all you have to do is press another key, and you'll go right back to the dial mode, and you'll get the regular dial tone. In addition, if you dial an extension that doesn't exist, it's going to give you a recording of me simulating the AT&T lady, because why not? That was kind of fun to record and burn into the firmware there. So the version 0.31 includes USB interfaces that enable us to connect it to the computer and effectively put the device into a pass-through mode when it detects the presence of an application that's pulling data from it. So we have a couple different modes. We have NC for not connected. So if you just plug this right into like a USB charger, you're going to get NC because it's not connected to a computer. The inactive means that the device has been enumerated and is recognized by the computer. So if you run ls USB, you're going to see that device there, but the program that's controlling it and interfacing with it is not running. And if that program hasn't been detected in a period of time, it'll switch back to the inactive mode and just function as regular line simulator. There is a dip setting now to switch it to computer only if you're going to be using this for only switched operation, and you want to make sure that it's not going to ever present the line simulator mode, which can be a bit confusing if people didn't know that that was there. There's a dip switch you can flip, and then it will essentially give a busy tone to people until such point that you connect the computer to it. So let's take a little look at that console application. So briefly, as soon as we execute this console application, you're going to see it has enumerated all the devices here and is now presenting them in order. In this case, we have 8 phones available because we have 2 switches connected to it, which is 8 total lines. And I haven't quite tested how many we can get away with, but it's probably quite a few because the bandwidth requirement for these is not high. It's about 4 bytes a millisecond in data payload plus some, overhead for status communication. So there's two representations of state here. We have the switch state, which is kind of a representation of what you're seeing on the display here, which is presented on the console. And then on the right, we have the computer state. In the N column, you'll see the dial digits, and R is the recording index, which you'll see. So if I take this phone off the hook now with the USB console connected, you're going to see I get to USB dial. And you're going to actually hear a precise tone plan dial, an output dial, whatever you want to call it. And you'll see that recording is ticking along. So the dial plan here is 0, 1 up to however many phones you have at the moment. And so what we can do is dial 0, 1, and it's going to trigger that phone to ring. And it may seem like this is exactly the same thing as before, but I can actually press this button and communicate between these two phones just as if they were connected to the same switch. And in the background, the data is actually being passed from this phone to the switch over the USB endpoint through this console application, which has connected the two phones internally out to this switch targeted to this phone because they dialed each other, which was pretty fun. The reason we implemented this first is because of a proof of concept, so we just wanted to be able to show that we could do that, and also that we wanted to be able to enable just basic functionality without getting anything too complex. So this is just a basic console C application. And to be fair, this should be considered a proof of concept. This is not production-ready code. I'll be working on that. Version 0.31 has a few bugs. Sometimes if you dial, it doesn't ring the first time. Working on all that. But yes, we have additional modes, USB dial and USB traffic, that are both passed through. And those will enable console applications to interact with this. And in future plans, we want to interface this with Asterisk or some other internet-connected capacity so that we can interconnect these just like a regular phone. If you exit this program, so that it was an incursus window basically, but what you can see is that it's loading some recordings, and then it goes through and enumerates the devices. And one of the things to note is that each interface, their CAFE6942, of course, is our vid PID, but it's going to enumerate the firmware version as well as a unique ID there, the serial number row there, and that is actually a hex-encoded version of the unique board ID inside the Pico. That's going to enable us to individually identify each of these boards, and if you have a configuration file, you can assign what order you want and map extensions to them, etc. And it also enables this to understand the version that it's talking to and ensure that it's compatible. In addition, the update button is not accessible when it's inside the case, so we implemented an extra button that's connected to a GPIO pin, and it's polling for that and will throw the device into a firmware upgrade mode. One of the other fun features I got working was this feature, where you can actually throw a packet over on the control endpoint using a vendor-specific command, and it'll throw this into firmware update. That will mount your Raspberry Pi Pico for a firmware update. And we'll be able to use this to do seamless firmware updates and stuff like that. That was my first thing I actually got working on the USB side. So stay tuned. I'm going to go over a lot more about this, but I just kind of wanted to get this video out there because we are shipping these and a lot of people had questions about how they're used specifically. And so I just wanted to go over top to bottom of what we got working. And we'll sort of be covering the firmware side, the USB side, the codec side, a lot more of the stuff we've covered in future videos. And don't bother looking in here, or if you are interested in what we're going to be doing with this and how we might interface these old school TA-312s with these phones, stick around. Maybe throw us a subscribe. Till next time, Nick with Nick's Knacks, have a great day.